In this video, we're going to cover higher order derivatives. So we will be using this prime notation. So for example, this is for the second derivative, and this is for the third derivative. But this prime notation will get messy eventually. Let's say we would like to get higher than the third derivative, so we may use this notation and this one. So let's say for the second derivative, we may use 2 here. And for the third derivative, this would be the notation. So let's say you would like to get the fourth derivative. We just need to change this to 4, and then same here. So let us try to answer some examples. So in this example, we would like to get the first, second, and third derivatives of the given function. So applying the basic differentiation rules, our first derivative would be 12x cubed minus 6x squared plus 8x minus 8. To get the second derivative, we just need to get the derivative of the first derivative. So that would be 36x squared minus 12x plus 8. And to get the third derivative, we need to get the derivative of the second derivative. So we have 72x minus 12. Let's say we would like to get the first and second derivatives of the given function. So let us apply product rule to get the derivative of the given function. So remember that we're using the formula u and then derivative of v plus v and derivative of u. So let us say this is our u and this is v. So getting the first derivative, that would be, so we have u. So let's copy 2x squared plus 3. And then the derivative of v, so this would be 6x. Plus v, so we just need to copy this one. So we have 3x squared minus 5. And the derivative of u, we have 4x. Simplifying, we need to multiply 6x by 2x squared plus 3. So this would be 12x cubed plus 18x. Plus, multiplying 4x by 3x squared minus 5. This would be 12x cubed minus 20x. And combining like terms, we have 24x cubed. And 18x minus 20x is negative 2x. So this is our first derivative. Getting the second derivative, we just need to get the derivative of the first derivative. So we have 24 by 3 is 72. And this would be x squared. And then the derivative of negative 2x is negative 2. So this is the first derivative, and this one is the second derivative. So for this example, we need to get the second derivative. So for us to get the first derivative, let us use quotient rule. So let's say this is our u and this is our v. So we will follow the formula v and then u prime minus u times v prime over v squared. So we have v is 2x minus 5 multiplied by u prime, and that would be derivative of 4x plus 3 is 4 minus u, 4x plus 3, and the derivative of 2x minus 5 is 2 over the square of 2x minus 5. So simplifying, you have 8x minus 20 minus, this would be 8x plus 6 over the square of our denominator. And simplifying, this would be 8x minus 8x, it would be cancelled. So what's left would be negative 20 minus 6. So this would be negative 26 over the square of 2x minus 5. So this is our first derivative. To get the second derivative, we just need to get the derivative of this answer. So let us write this first in negative exponents. So this can be written as negative 26 and then 2x minus 5 raised to negative 2. So that we can apply chain rule in this function to get the second derivative. So applying chain rule, we have negative 26 times negative 2, and then let's copy the inside function. And then this is negative 2 minus 1. And then this is the inside function for the chain rule. So we're going to multiply this by 2, because that is the derivative of 2x minus 5. And to simplify, negative 26 times negative 2 times 2 is positive 104 times 2x minus 5, and we have negative 2 minus 1 is negative 3. And then we can write this as 104 over 2x minus 5 and then cubed. So this is our second derivative. So let us now get the fifth derivative of cosine 3x. So remember that the derivative of cosine u is equal to negative sine u and then times du dx. So to get the first derivative, let us get the derivative of cosine 3x. So this would be negative sine of 3x and then times the derivative of 3x, and that would be 3. So this would be negative 3 sine 3x. For the second derivative, we need to get the derivative of negative 3 sine 3x. And remember that the derivative of sine u is equal to cosine u and then times du dx. So the derivative of negative 3 sine 3x is negative 3 and then cosine 3x times 3 for the derivative of 3x. To simplify, we have negative 3 times 3. This would be negative 9, and then cosine 3x. For our third derivative, we need to get the derivative of negative 9 cosine 3x. So we have negative 9, and then the derivative of cosine 3x would be negative sine 3x. Derivative of 3x is 3. So simplifying, negative 9 times negative 1 times 3 is positive 27 sine 3x. For the fourth derivative, we have to get the derivative of 27 sine 3x. So this would be 27. And then the derivative of sine 3x is cosine 3x times 3. So simplifying, this would be 27 times 3 is 81 cosine 3x. For our fifth derivative, we need to get the derivative of 81 cosine 3x. So we have 81 times the derivative of cosine 3x is negative sine 3x times 3 for the derivative of 3x. And then simplifying, this would be 81 times negative 1 times 3 is negative 243 sine of 3x. So this is the fifth derivative of cosine 3x. Let's say we want to get the second derivative of secant 2x. So remember that the derivative of secant u is equal to secant u tangent u times du dx. So let us first identify the first derivative. So this would be, our u is 2x. So we have secant of 2x times tangent of 2x. And then the derivative of 2x is 2. Therefore, our first derivative is 2 secant 2x times tangent 2x. Now, how do we get the second derivative? In this case, we can set 2 secant 2x as u and then tangent 2x as v. And then we can perform product rule. So we have u and then derivative of v plus v and derivative of u. So following this, u is 2 secant 2x. And for the derivative of v, we need to get the derivative of tangent 2x. So remember that the derivative of tangent is equal to secant squared u and then du dx. So for the derivative of tangent 2x, we have secant squared 2x and then the derivative of 2x. So that would be 2 plus v. So let's copy tangent 2x and then the derivative of u. So we have 2 and then derivative of secant 2x. So this would be secant 2x and then tangent 2x. And we need to get the derivative of 2x. So this would be 2. Simplifying, we have 2 times 2 here. We have 4. And then we can combine secant 2x and secant squared 2x. So this would be secant cubed 2x plus 2 times 2. We have 4. And then let us combine tangent 2x and tangent 2x here. So that would be secant 2x and tangent squared 2x. So this is now the second derivative of secant 2x. Let's say we would like to get the third derivative of the square root of x. Remember that square root of x is the same as x raised to 1/2. So to get the first derivative, okay, let us use chain rule for this one. So we have 1/2 times x and then raised to 1/2 minus 1. And then the derivative of x is 1. So this would be 1/2 times x and then 1/2 minus 1 is negative 1/2. For the second derivative, this would be 1/2 and then multiply it to negative 1/2. And then we have x raised to negative 1/2 minus 1. And then the derivative of x would be 1. So simplifying, this would be negative 1/4 x raised to negative 1/2 minus 1, negative 3 over 2. For the third derivative, this would be getting the derivative of negative 1/4 x raised to negative 3 over 2. This would be negative 1/4. And then let us have the exponent, negative 3 over 2. And then let's have x, negative 3 over 2 minus 1. And then the derivative of x is 1. So simplifying, this would be positive 3 over 8 x raised to negative 3 over 2 minus 1 is negative 5 over 2. Or we can also write this as 3 over 8x raised to positive 5 over 2. Let's say we'd like to get the first, second, and third derivatives of y is equal to sine squared x. So remember that the derivative of sine u is cosine u and then times du dx. So for this case, we would be doing chain rule to get our first derivative. So we have 2, and then let's copy sine x, and then we have 2 minus 1. And then we need to get the derivative of sine x. So the derivative of sine x is cosine x. And then times du dx, or the derivative of x is 1. So simplifying, this would be 2 sine x times cosine x. For the second derivative, let us have 2 sine x as our u, and then this is our v. So that we can have the product rule, u and then v prime plus v u prime. So following this, we have our u is 2 sine x times v prime, which is the derivative of cosine x. So again, the derivative of cosine u is equal to negative sine u du dx. So the derivative of cosine x is negative sine x plus v. So let's copy cosine x. And the derivative of 2 sine x is 2 cosine x. So simplifying, this would be negative 2 sine squared x plus 2 cosine squared x. For our third derivative, we're going to get the derivative of this term, negative 2 sine squared x plus, and the derivative of 2 cosine squared x using chain rule. So doing that, we have negative 2, and then for the derivative of sine squared x, we have 2, and then let's copy sine x, then this would be 2 minus 1, and then the derivative of sine x is cosine x plus, so getting the derivative of this term, we have 2. By chain rule, let us get the derivative of cosine squared x. We have 2, and then cosine x, then we have 2 minus 1, and then the derivative of cosine x, or the inside function, and that would be negative sine x. Simplifying, this would be negative 2 times 2, we have negative 4, sine x, 2 minus 1 is 1, and then cosine of x, and then we have 2 times 2 times negative 1, we have negative 4, then sine x cosine of x. And simplifying this, we have negative 4 sine x cosine x minus 4 sine x cosine x is negative 8 sine x cosine of x. So this is now the third derivative of sine squared x. In this example, we are asked to get the fourth derivative of the given function. So we need the formula for base e and for ln. So the derivative of e raised to u is equal to e raised to u times du dx. And for the derivative of ln of u, this would be u prime over u. So let us now get the first derivative. So we have e raised to negative 3x, and then the derivative of u, that would be negative 3, plus 4, and then the derivative of ln 2x raised to 4. So let's say this is our u, 2x raised to 4, and then the derivative of that is 8x cubed. So we have 8x cubed over u. So this is 2x raised to 4. So simplifying this one, we have negative 3 times e raised to negative 3x is negative 3e raised to negative 3x plus, this would be 4 times 8, 32 over 2, that's 16. And then x cubed over x raised to 4 is 1 over x. So this would be x. So this is our first derivative. Now for the second derivative, we are getting the derivative of our answer here. So we can have negative 3 and then e raised to negative 3x. And then the derivative of negative 3x is negative 3. So let's have the 16 over x as 16x raised to negative 1 so that we can apply power rule. So we have negative 16 x raised to negative 1 minus 1. So simplifying, this would be negative 3 times negative 3 is positive 9, e raised to negative 3x minus 16, x raised to negative 2. So this is our second derivative. For the third derivative, this would be 9e raised to negative 3x times negative 3. Here we have negative 16 times negative 2. That would be positive 32x. And we have negative 2 minus 1 is negative 3. So simplifying, this would be negative 27 e raised to negative 3x plus 32 x raised to negative 3. So this is our third derivative. For the fourth derivative, so we have negative 27 and then e raised to negative 3x. And the derivative of negative 3x is negative 3. And then we have 32 times negative 3 is negative 96. X raised to negative 3 minus 1. So simplifying, so we now have positive 81 for negative 27 times negative 3. And then e raised to negative 3x. And this would be negative 96. X raised to negative 3 minus 1 is negative 4. So this is our fourth derivative. For this example, let us solve for the second derivative of e raised to x sine x minus 3e raised to x cosine x. So for this example, let us write this as e raised to x times sine x minus 3 cosine of x, since e raised to x is a common factor. And then we can apply product rule to get the first derivative. So let's say this is our u and this is our v. So again, we would be using product rule u and then v prime plus v times u prime. So following that formula, u is e raised to x times the derivative of v. So the derivative of sine x is cosine x. And the derivative of negative 3 cosine x would be negative 3 times the derivative cosine x is negative sine x. So it would give us positive 3 sine x plus v would be sine x minus 3 cosine x. And the derivative of e raised to x is e raised to x. E raised to x is a common factor, so we can have this as e raised to x times cosine x plus 3 sine x plus sine x minus 3 cosine x. So combining like terms, we have e raised to x times cosine x minus 3 cosine x. This would be negative 2 cosine x. And for 3 sine x plus sine x, we have plus 4 sine x. So this is our first derivative. For the second derivative, let's have this as u, and this is our v. So following the same formula for product rule, we have e raised to x times the derivative of negative cosine x plus 4 sine x. And that would be positive 2 sine x, because the derivative of cosine x is negative sine x times negative 2, that would be positive 2, plus 4 cosine x, plus v, so we have negative 2 cosine x plus 4 sine x times the derivative of e raised to x, and that would be e raised to x. So e raised to x is a common factor, and then we can have this as 2 sine x plus 4 cosine x minus 2 cosine x plus 4 sine x. And then simplifying, we have e raised to x times 2 sine x plus 4 sine x would be 6 sine x. And then we have 4 cosine x minus 2 cosine x. That would be 2 cosine x. So this is our second derivative.